Hello and welcome to the Scientific Adventures of Beardman. Today we're going to be looking at a concept builder on physicsclassroom.com. Title is Words and Graphs. It's in the topic of kinematics. All right, so this one is going to give you a little description and have you draw a velocity time graph. If you are not familiar with velocity time graphs, I'm going to link right here my video that explains velocity time graphs. I would highly recommend looking at that before you try and apply all this new knowledge to your graphs. All right, so first one, there are 8 different types of things you'll see. You'll see 2 in each one. They pair them up so they look similar, but you'll have to look at them very closely because they are a little bit different, okay? And so just make sure you are being careful. But there are 8 different types of things you'll see. 6, I think, in the apprentice level, then it adds 1 more for the master level and 1 more for the wizard level. But the master and wizard level have all the first 6 as well. So this one, a card holds its position at 24 meters for 7.0 seconds. All right, so one of the key words here is that it holds its position. In other words, it's staying in the same place. Well, if you've ever been in a car that's staying in the same place, you know what the speedometer reads. The speedometer reads 0. So anytime you see this one, no matter what the numbers are, you'll see a straight line across. I guess it'll go across to the time because it says for 7 seconds. Okay, so that's what you'll see here. This 24 won't show up anywhere in the velocity time graph. It would be in a position time graph, but this concept builder is about velocity time graph. All right, next one. A cart moves with a constant speed of 9 meters per second for a time of 3 seconds. Okay, so this one's fairly straightforward. We're looking for what its velocity is at each point in time, and it says its speed or velocity is going to be constant, and it's going to be 9 meters per second. So look for a little mark that says 9. This should already say meters per second. Okay, but you just look for a mark that says 9. You'll see a little dashed line go across. No, you won't, because that's where it is the whole time. You'll see a straight line go across until you get to 3 seconds, and seconds will be with the thing over here, maybe in parentheses. Okay, all right, so it's going to stay at 9 the whole time for the full 3 seconds. That's it. These little dashed lines just help you see that the end of the line is at 3. All right, so moving on to the next one. That's the same one. How do I get to the next one? Oh, I gotta go back to mouse, I guess. There we go. Okay, a cart slows down from 16 meters per second to a complete stop in a time of 4 seconds. All right, so first of all, we see it's gonna go to a complete stop. Okay, so that means it's gonna end up at 0. Okay, it slows down from 16 meters per second. So that means it's starting out at 16. So it's going to go from 16 to 0. And that will happen at a time of 4 seconds. All right, next one. Starting from rest. Okay, so from rest, that means it has 0 velocity. That's what we mean by from rest. Speeds up to 7 meters per second. So we're going to have 7 meters per second there in a time of 2 seconds. So you'll see little dashed lines or dotted lines. I forget if they're dashed or dotted. And the line will go from 0 to 7 meters per second over the course of 2 seconds. All right, next one. All right, now we're going to get a little bit more complicated. We got acceleration in here. If you are not familiar with acceleration, I'm going to link here the video I made on acceleration. That video starts out with some dot diagram work, so feel free to skip to where it teaches about acceleration. And you can see where this all comes from and what exactly it means. But I'm going to breeze through that and just apply what we need to. So first of all, this says starting from rest. If it starts from rest, first of all, it's going to start at rest on our graph here, but it also means the initial velocity was 0. So we can ignore that term. 0 doesn't affect our subtraction there at all. Okay, so we've just got A equals VF over T. Okay, and notice it doesn't tell us what our VF is, and so that's why we're going to need this equation. We've got the 3 seconds. We know it's going to go to 3 seconds, but it's speeding up at this acceleration, meters per second per second. Sometimes you'll see that written meters per second squared, so you might be more familiar with that. But meters per second is the same thing. And if we're trying to find the final velocity, we're going to have to multiply both sides by t so that the t leaves the denominator. Okay, so we get VF equals AT. Okay, while I highly recommend you're able to do that algebra, this is the equation you're going to need. So we take the acceleration, 12 meters per second squared, or meters per second, times the time, acceleration times time. Time is 3 seconds. And 12 times 3 gives us 36 meters per second. Notice that second cancels with one of the squared ones. Okay, and so we'll get a graph that looks like this. Once again, starting from rest, that's why we started here, speeds up at a rate of this. That's an acceleration, so we don't see 12 on a velocity time graph. So we had to calculate our final velocity, which was 36. And so we sloped up to 36. Every second, it changed by 12. So there's 12, 24, 36, because we did it for 3 seconds. All right, next one. Another acceleration type one. A cart slows down. So now we got the opposite thing going on. We're going to slow down at a rate of negative 9 meters per second squared to a complete stop in a time of 3 seconds. Okay, so it's going to end up at a stop here. That means that the final velocity is 0. Okay, so now we have A equals negative VI over T. All right, and if we want to solve for the initial velocity, so we know where to start up here, we have to multiply both sides by t. That'll cancel out the t's, and there's our equation, negative VI equals t times A. So we take t, which is 3 seconds, that's right here, and our acceleration right there. So 3 times negative 9 meters per second squared, or meters per second, gives us, and then we could just take this negative here and subtract both sides. So we multiply both sides by negative 1, and we get VI equals negative AT, or negative TA. So we have a negative out there. So we get a 27 seconds cancel meters per second. Okay, so we start at 27 meters per second, and we slope down to 0, and that takes 3 seconds. Okay? All right, so once again, here is our equation. I had forgotten to move the negative over the first time, so we have the initial velocity equals the negative of A times T. All right, so that is enough to get you through the apprentice level. For the master level, you'll need to be able to do this type of problem as well. Okay, so here we see a cart moves with constant speed. So it means whatever line we're at, it's going to go straight across. And it covers 12 meters in 3 seconds. Well, 3 seconds is a time. The 12 meters is a distance, or you might see it listed as a displacement. Okay, either one, your teacher may have used either one or both. All right, so then if we want to figure out the speed or velocity, we just plug right into this equation. The distance was 12 meters, the time was 3 seconds, and the velocity or speed is 3 meters per second. So 4, we put that 4 there, and a line straight across to 3 seconds, because that's going to happen for 3 seconds. And that's what your graph will look like. All right. The next one is, well, that covers the master level. And now the wizard level has problems like this. Okay. So here we have starting from rest. Okay. So we're starting at 0. We're going to speed up again. Okay. So we know we're going to speed up, and we know it's going to be for a time of 3 seconds. The question is, how fast will it be going? What do we know? We know it covers a distance of 12 meters. Okay, well, let's use our equation again. It's the same as on the last slide. The numbers are. So we'll just plug those in. That's 4 meters per second. Okay, so but what is this? This is the average velocity. Okay, sometimes it's written a V with a line over it. That's the average velocity. And we clearly do not have a constant velocity. It is changing, but it's changing in a very consistent way. It's a straight line sloping up. So what would the average be? Well, the average would be whatever the middle value is, because half of it is lower, half of it's bigger. This amount that's bigger is the same amount bigger as this part is smaller, because it's a straight line. Okay, so if this average is 4, well, then the final is going to be 8. You just double it. Okay, so the final velocity is 8. There are ways to do this using the average under the area under the slope to find the distance and so forth. But this is the method that I find easiest for students. And it helps you understand the concept here that this is its average speed, but then the final speed is the key thing that we want for the graph. So the stuff that I drew on blue on here, that is not necessary. You won't see any of that on the graph. It's only the stuff in red here that you will see on your graph, because that's the final speed. That's where it gets to eventually. Because it averaged 4. From 0 to 8, it averaged 4. All right, and that should be enough to get you through all 3 levels. Puzzle it out. Read carefully, though, because those little tiny words like from rest or to a stop, from and to, all those are key words, so make sure you're paying close attention. If you have any questions, put them down in the comments. If you learned it well enough to complete your concept builder, please click the like and subscribe button, and I'll see you the next time on the scientific adventures of Beardman.